Okay, so hi everyone, and it's closing to lunch. I will try to be fast. First, a little bit introduction to myself. My name is Shushu and I work in Nokia Bell Labs in Finland. My research has been mostly focused on security and privacy. The middle part is the kind of solutions tools I have been using mostly, and at this moment, my research topic is mostly related to machine learning and cross-chain DLT-based marketplace trust management. If any of you are interested in this kind of topics, I'm open to collaborate. So my presentation today actually will continue with confidential 6G program. Maybe you already heard quite a lot about the background from Veja and Louis from the morning session. So this presentation I'm having today is actually a subtask of the whole project. It's the task 4.1, sorry, and we had a deliverable document from last December, and you can find the document actually on the link I provided here. This document is joint collaboration between different parties. Okay, so I'm starting from here. A little bit introduction to the 6G architecture. So 6G has been discussed for a while, and hopefully it will be coming to the commercial in 2030, hopefully. And for the architecture, here is what has been fantasized. So generally, the 6G architecture for the infrastructure layer will be widely applied on the access of the distributed radio access network, and also the terahertz spectrum, to generally compared with the 5G network, it will have the higher capacity and the lower latency. Meanwhile, this black box here is the network function and services that the focus in the 6G. And based on this kind of infrastructure, the key architecture change to the 6G will be actually on the network service layer, so which mostly will be transit to the cloud native or microservice architecture. The research around this topic is quite general. It could be the edge cloud or core cloud or public and private cloud. They have different research around them, and in the core network of the 6G, it started to develop the industry verticals to satisfy the different functional and technical requirements. Possibly in the future, let's say the collection of the Internet of Things and time-sensitive network has been very popular. On the top layer with the management and orchestrations, so 6G network will definitely be integrated with the emerging AI and new hardware components. So with all these developments and the components that are involved into the 6G, so 6G security and privacy design would definitely require a new regime. That's why I'm here to presenting you the new future for the security and privacy solutions in this kind of architecture. So still going back to confidential 6G, so we all know it's a EU project and focusing on the security and the privacy. But the main research architecture is, as I presented before, that trying to find the privacy solutions using the cryptography techniques and to supporting the cloud and the edge communication. Three main research pillars. The first, the cryptographic. It's dedicated to find or define the new crypto enabler solutions. Like you may already heard about fully homomorphic encryption, secure multi-party commutation, a trusted execution environment and DLT technology and so on. So this is very general. We try to adopt all the available crypto solutions. And the second part, the confidential computing as presented in the various morning session, then trying to keep the data in use and using the trusted execution environment and the containers technology. And the last pillar, the confidential networking, is trying to target the data in different architecture when they transfer from one node to another, and focusing on the post-quantum side and the secure network protocols, data access and general, and using the available, mostly the blockchain technology and federated AI. Of course, in this presentation, my focus is actually on the confidential networking side. I'm going to show you some initial architecture design solutions. We have been really focusing on this confidential networking topic. So first is the basic problem. What's this confidential networking? As you can see here, the cloud, the edge device, and the users. These are like a lot of different entities in the network, and when the different services and the data transmit between them, we have to make sure the data is protected. So, and the use case is in these three applications. The most popular one may be, as we always talking about, federated learning as a services and Internet of Vehicles or secure decentralized data sharing are the main research focuses. So generalized from these three research focuses, we can actually summarize here, providing you a summary of the main characters of the confidential networking. So first we need to aims to ensure the secure data exchange and sharing over the cloud or edge especially. And the second is focus on the orchestration mechanism to improve the data privacy during the federated scenarios. And the last point is data verification and access control mechanism that normally could be leveraged by using the blockchain networks. Before we go into the final architecture design, we first go through the requirement for the confidential networking. So based on the three use cases I just mentioned, we can trying to extract the main requirements for the confidential networking. We extracted the main requirements, maybe around 100 of them from the different parties that joined this program, and focusing on the three use cases we just mentioned. And on the right side is an example of the a summary table we used. We provided the requirement and a little bit description, and all the requirement is collected from the four categories you see here. We're focusing on functional and non-functional, and also security and regulatory requirements. Yeah, but too easy to understand the way later we summarize all these requirements into a general module as we presented here. These four modules is the main research problem we come to the confidential networking side. So the first step, the first one is the orchestration part. The first module, the orchestration mechanism, it's about deploying and configuration of the applications, algorithms to different to different parties in a confidential manner. Nowadays, it's maybe more popular using the trusted execution environment or container services that has been really popular to solve this. And the second, data sharing mechanism. It's mostly focused on the data's confidentiality, integrity, and traceability when the data is shared between the complex networks, 60 networks, and the federated AI. Since the AI is generally a little bit different structure from the existing networking structures, so it actually asks for a separate part to address the problem in the federated AI. And except apart, of course, the federated AI itself already provided some security or privacy for the end users without sharing their data to the cloud. But meanwhile, the poisoning attacks and every attacks that focusing on the federated models is also the threat to the 6G. The last module is about called long-term security. It's basically targeting the quantum-safe communication channels. So, and a good design would really like considering all these modules, like the factors required, and then fulfill this requirement. So to really fulfill these requirements, we of course need to leverage the cryptographic techniques. This including both the software side and the hardware side. Okay, so now I'm going to the fruit part of this presentation is the architecture for this different modules, how we can, the research problem we have been focusing and how we can initially have a design to solve it. So the first one is confidential orchestration. That could be solved the orchestration mechanism required, because generally orchestration involves the deployment of data or algorithms and the executions of the cloud and the edge and different parties. So it's kind of challenging to really cooperate between these different parties, and the container services could be really applied here to orchestrate all this information across different parties. And the initial design here is promoted by VTT, and it provided a solution that's trying to help cloud and the client to communicate with each other in a healthy way, in the privacy way. And on top of the dash line is some confidential, the direct communication between them, and it's definitely not secure enough. So then to implement this security, we have provided two modules here. One is called encrypted container, which is generated implemented based on the existing privacy solutions like a homomorphic or secure multi-party and post-quantum, etc. And another one is trusted containers, which is directly deploy of the trusted execution environment, like which can allow the remote station to cooperate between different clients. Second part is the data sharing mechanism, and as you may already heard that to really achieve the data integrity and the traceability, then the DLT or blockchain technology is come to use. And here with the inherent security and the immutability of the blockchain technology, it can be created for the data sharing between the different platforms across the whole network, thus enhancing the traceability and transparency and everything into the network data. Besides the potential combination between the blockchain and trusted execution environment could also be considered here to providing a better privacy protection generally. And the next one is the federated learning. We have been talking a lot in this in today's workshop, and you must already know that federated learning now providing a central server to communicate to collect all the parameters from the different clients, and then without the need to really getting the data from them directly. Of course, this solution can providing a very good protection to the clients, but meanwhile, a lot of attacks that focusing on the server side is the concern to the further application of this model. And the research we can see here, we generally provided two. First is trying to deploy using the blockchain technology actually to providing a poisoning defense strategy for the federated learning scenario. And the second one is actually I think it's from the wing side. Okay, it's using the explainable AI technology to interpret the parameters that are collected from users, and thus to when they really detected some sensitive parameters, they will just directly block the user or delete the parameters. Thus, the poisoning defense could be protected. Last but not least, as we see, is the transport layer security. So TLS generally implements the end-to-end security for the data for the users over the internet, and providing the authentication solution for different parties, and allows them to communicate their information in a secure way. And this, of course, will continue in the 6G scenario, and this is almost the most important in the internet network data transaction on the networking side. So to really improve the post-quantum over the TLS is very important work in 6G. And for the long-term security, we have to design the post-quantum solutions for this TLE-based algorithms. And a simple solution would be really to replace the main modules, the key exchange and the digital signature, with all the existing quantum safe algorithms. And I already mentioned hybrid schemes for the future, because the existing post-quantum solution may be skeptical, and then when the quantum safe solution is not available, then we have still go back to the legacy algorithms. Yeah. So just to summarize here, this whole presentation is mostly to present you an idea of what the confidential networking has been doing, and what kind of research aspect we have been targeting, and the initial solutions to all these research problems in the confidential networking side. If you have any questions, because I'm not really an expert on this specific topics, you can I mentioned there the organization name. You can contact directly with the colleagues that I put on the second page, sorry. And yeah, that will be my presentation. Thank you.